Hello, technicians, and welcome to another edition of the Life Safety Troubleshooter. My name's Gary, and let's get right into it. What I'd like to talk about in this episode is the dreaded invalid replies with no set pattern. They get to be a little irritating, and the reason that they're no set pattern is because what's causing these invalid replies is normally going to be a device that's causing intermittent shorts at different potentials. So it's not a dead short, it's more of a floating short. Sometimes it'll go up, down, middle, but there's a way to find this. There's a couple ways that you can actually find this. One way that you can find it is by using this meter and the cob box, as I indicated in my first episode. So what you can do is you could go ahead and disconnect your SLC circuit and go polarity conscious on the positive and the negative. And what you're going to read is you're going to read the current is going to ramp up. And then it's going to slowly drop, and it's going to stabilize. Well, the reason it's ramping up is because you're reading all these capacitors and all these devices out there in the field. And until they charge up, you're going to see a considerable amount of current draw. So once this is stabilized, basically the rule of thumb ballpark is going to be 5 to 6 milliamps for, 5 or 6 devices for every milliamp. So you do that and you count them up. You figure I've got 100 devices, so I should read about 20 milliamps. Well, that's with the cob box now, you understand. So now if you read 30, 40 mils, you know something out there is drawing too much current. So that's the first thing you do. But let's say you read it and it looks okay. You've got the mils compared to the devices are okay. So the next thing you want to do is you want to use a different method. And first you have to establish what is your problem. So sometimes what you can do is you could use a logging meter. Now this particular logging meter I have set for 20 milliamps per block. As you can see, as I short things intermittently, it's reading that. So let me go ahead and put this up for you so you can see. And I'm going to go ahead and put the logging meter in there for you so you can see that. So you can see what I'm doing. So I'm taking this piece of wire inside of here, and I'm intermittently shorting it out. A little bit here, a little bit there, and then I'm going to put a dead short on it. I'm going to leave that dead short there for just a little bit. You can see it goes up to maximum potential, about a 95 mils. And as I release it, it goes back down. Then you'll see if I go back in again and do the intermittent thing, it's going to read it. Now, this is going to allow you to determine that this is your problem, okay? So you want to put this logging meter up here on the head end first. And you want to do it hot on the SLC. So leave your SLC hooked up. Break one side of your circuit and go ahead and put that logging meter in series with the circuit so you can watch what it's doing. So you're going to watch this with the logging meter. And what's going to happen is you're going to have what's called a bandwidth, is what I call it anyway. You're going to have a bandwidth, and it, depending on how many devices you got on there, it might be 20 to 30 mils, it might be 40 to 45 mils. It just depends on if you're working on an older analog or clip addressable loop or a flash scan loop. Readings will be a bit different. So you're going to watch this and you'll see it floating in the bandwidth. And here's another meter that I use that basically allows you to export it to an Excel file. Now, as you can see in this, you see when I'm talking about bandwidth, you can see these lines here right around, say 100 mils. So it's a pretty good size circuit. It's flashing between, say, 60 and 80, somewhere in there. That's your bandwidth on this particular circuit. I don't remember if this is an older panel or a newer panel, probably an older panel. But you can see, and this was one of these instances where it was the invalid replies with no set pattern or no answers. You can see where the bandwidth goes down, and all of a sudden you get jumps, you get spikes. You see sometimes the spikes go up to 100 mils, 200 mils, 150 mils, and some of them peg out. So what that does is it drops your circuit, drops your SLC circuit, and you start getting invalid replies. And depending on when this takes place, depending on what your history will tell you as to what devices went invalid. So now, basically, you're looking at that and you see this. You see this. So you know, okay, I have something out there that's drawing too much power. So just so you know, just some of the readings you can read with the cob box and a regular meter. So you can use this and you can go and read individual isolated devices like a relay, a smoke, a single module, a double module. Now, relays read usually about 140 microamps. The newer ones read about 40. They've improved the circuit, uses less current. Your smokes, they're in about 300 microamps. Your single modules are right around 250 microamps. Your double modules are right around 450 microamps. So knowing this, and then going out there and putting that logging meter out there and going, okay, this is what I see with this logging meter. This is what I see with that logging meter. But let's go ahead and stick with this logging meter. So you see the problem out there. You get yourself a logging meter. And the more logging meters you have, the better off you're going to be. Because what you want to do, and here again is your circuit, and I'm going to put that logging meter on there again. We've already got one on there, so we've established that we have something drawing power. So now we're going to break the circuit, and we're going to put another logging meter on there. Now, I know these logging meters aren't cheap, but then again, labor is a lot more expensive. The faster you can do this and the less hours you spend in it, the more money you save, depending on this, if this is a maintenance contract with the customer that you're going to take care of it, or even if it's a chargeable call. So now we have two logging meters on here. Let's go ahead and put another logging meter, say right here. Let's put another logging meter there. And let's put one more logging meter down here. So now we got 4 logging meters on the circuit. We're looking at this and we go back the next day, or if you're lucky enough, it'll do it to you while you're there and you've got these things hooked up. You're going to go in here and read these and you're going to go, okay, I got a short. Now, right here is where your short is, but right now you don't know that. You don't know that it's this FRM, which is normally the ones that do it. I'm not saying that the mini modules or the single or dual modules don't do it. It's very rare for a mini module to do it. It's more common for an FDM or a dual module than it is for a single module. But by far, it's been FRM. So we don't know what's there, but now I'm going to tell you how you find out. You read this, you see spikes, you see about 70 milliamp spikes. You read here, you're reading about the same. You read here, you're reading about the same. You read here, you're reading about 0. So you know your problem is between these 2 points. So now, here's the thing. Let's say you've got let's say you got a couple more modules in here. Let's say you got a module there, and you got maybe another module here. So let's say you've got 4 modules on this circuit after this point. After that point there. So, or here's 2 modules. So the way you tell which module it is like I was saying before about approximately how much each one of these devices are. So you take your cob box and you go out there and you isolate these modules and you read them with a cob box. Now, if you read this relay module and it's reading 170 microamps and it stays there, and you got to watch it for a minute or two to see if it moves around, you're good. But now you get to the bad one. You know this should be your target current, 170 microamps. Now you look at this thing and you go, oh my, okay, I've got 170 mics on this one, but this one I'm reading 220. All of a sudden you see it climb, 300, 600. That's the bad relay. The one that's doing that is the bad relay. These are hard to find, but not impossible. You have to depend on a live circuit and using logging meters, as I'm showing you on the screen now. And let me just go ahead and hit this again to show you what happens when it sees a short in there. You'll notice, there it goes. It's showing the spikes going in there on your graph, which is a whole lot better than trying to look at that meter and go, oh, I see it floating, because guys, it's going to float. And you're not necessarily going to notice as much that it's staying within the bandwidth by using that meter than you are, of course, using the logging meter that has a graphic function. So now you found that, you've replaced it, it's all good. So let me just go over again what you're looking for. Now, like I said, you can hook this up to a cob box. On this diagram, you can hook this up to a cob box, 5 to 6 devices per milliamp, and let it cook for a minute or two, because you need to let that reading settle down, because you're charging those capacitors in those devices. And then just watch it. I mean, if you see this thing starting to ramp up from 20 mils or 25 mils, because now you're not within a bandwidth, you have a solid just battery supply. So you're looking at a fairly stable current draw. You are going to see it move about a bit, but for the most part, it's going to be relatively stable. So if you see this thing going up 1, 2, 3, 5 mils, that in itself is telling you that you have a problem. Now, if you're lucky enough that it's doing it and it's doing it consistently, you can go out in the field and basically go, okay, where's it at by isolation. Now remember, when you're doing it with the cob box, you have to break it, because if you don't, the battery supply is going in two directions. So if you read it here and you're reading across the circuit, you're not necessarily reading in any specific direction to or away from the panel. So you have to break it. So you may break it here, and then you're going to read here and here. Now remember, your current draw is going to go down because now you have less devices, but still it should stabilize at a certain point, be relatively calm, and then you can watch it. You can see if it starts to ramp up. You start to get 1, 2, 5 mils of additional current. You go, okay, I know it's down this way. It's the old troubleshooting of divide and conquer. No building is too big, and I have found these things in 22-story buildings. I have found these in million-square-foot warehouses. I have found these in stadiums. So it is possible to find this. If it's doing it consistently, it's possible to find it in one day. But if it is highly intermittent, that's when you got to go with putting these logging meters out there and finding out what section of this circuit is the problem. Now, if you get it down to a particular section and you only got 2 or 3 of these relays out there, and you're not reading it with the cob box, which one of these relays is bad, I'd go ahead and replace all 3 of them. Heck of a lot cheaper than coming back most of the time, because labor is expensive. Customers are only going to go so far as service and how much they're going to pay to get this done, because they're just not going to understand. They're not going to understand when you send them a bill for $2,000, $3,000, $4,000 because you've had to take days and days troubleshooting this. So investing in these logging meters, however, whichever meters you want to choose to use, there are some different logging meters out there. Depending on how much you invest, how many meters you have, depends on how quick you're going to be able to find these. But remember, investing in these meters is usually going to be a lot cheaper than dealing with a customer who's going to leave you, or just flat not going to pay for your labor because they think you're milking the job. And obviously we've all had customers that do that and say, oh, you're milking me, you're charging me for all these hours. It's either you're milking me or you don't know what you're doing. So this is the way to find that. I hope that's going to help you finding these intermittent invalid replies with no set pattern. Now, there's another thing that causes this, but I'm going to cover that in the next episode, because that particular problem not only is totally bizarre, it's extremely difficult to identify sometimes, and it's 3 times harder to find. But I'm going to cover that in the next episode. So again, please like and subscribe and share this video. If you think I'm doing you good finding these things and you think I'm giving good advice, spread the word. I am here to try and impart my knowledge that I have over the past 47 years of how to find some of these things. There will be more videos. It won't just cover addressable systems. It'll cover NAC circuits, conventional circuits, and other troubleshooting methods, including my special tester, which of course I'm still in the process of patenting, but I'm hoping to get that out pretty soon, which is really a labor saver in troubleshooting. Again, technicians, good luck. Thank you for watching.